Um, so we're getting close to the end of the chapter. It's 8.5 applications of quadratic um, equations there. So this is kind of like the fun section. This is taking everything we learned and applying it to real life, and mainly it's going to be a nice little segue into physics for some of you next year. So in 8.5, the example number one says path of a ball. So found this sweet, sweet line. Okay, it's going to represent my ball. All right. And it says the height of a ball thrown by a child, aka me, okay, is given by the equation y equals negative 1/12 x squared plus 2x plus 4, where x is the horizontal distance in feet from where the ball is thrown. And then it asks some questions. So first off, let me throw the ball. So we got to go for a walk out on the deck. Yeah. And then you guys know about those neighbors that hoard all those rolls of toilet paper. So we're about to teach them a lesson here. So here it is. Here's the ball. And you got to throw it. And then we're going to break it down. So here we go. No more ball. So, after launching that ball at my neighbor's house because they've hoarded all of the toilet paper in the entire Aston Township, okay, where to go from there? So, here's where we go. The path that the ball took was parabolic. It went up, curved, and came back down. Okay, and we have an equation for that. All right, so we have an equation for the problem. It was given to us in the example, like actually in the uh, problem itself. So it said y equals negative 1/2 x squared plus 2x plus 4. So I wrote that right up here. And the first question asks, how high is the ball when it leaves my hand? So it's asking for this distance right here. Yeah, that's a good arrow. Look at that. So it's asking for this distance, okay? Now, how do I find that? Well, that's the trick here. So the trick is to know what are the two parts of my equation. So y is in feet and x is the horizontal distance. So notice the ball hasn't gone anywhere horizontally, okay? Meaning it hasn't left my hand. So I'm measuring the height and the length that it goes. So if I come up here and I want to know what is the horizontal distance it travels, okay, well, it hasn't traveled anywhere. So that means y equals negative 1/12 times x squared, but x is 0 because it hasn't gone anywhere. All right, plus 2x, well, x again is 0, plus 4. So the answer to A is just y equals 4. And when I think about that, that's a reasonable answer for the height of a child. Child is about 4 feet. For me, probably not reasonable. It means I'm a little short, okay? But in the context of the problem, yeah, 4 feet makes sense. Now, B says, how high is the ball when it reaches its maximum height? Well, when I launched this thing nailed a tree, okay? So I threw it pretty high. But when it's asking for that, it's asking you to find the maximum, okay? So now what I do is I can come here to my calculator, All right. And hopefully it loads. All right. But meanwhile, you guys can go ahead and type this in. So you're going to want to hit y equals, and then you're just going to want to type in that equation that they gave you. So we're going to type in negative 1/12 x squared plus 2x plus 4. All right, and we're going to hit graph, and we're going to see it looks like this. Okay, this is the height of me. And now my maximum's up here somewhere. So what I do is I'm going to go ahead and I'm going to zoom out. All right, so I'm looking for this point. So like I said, I want to find the maximum height. So let's go to calculate. Let's go down to maximum. And it asked me for the left bound. So I'm going to go over. I'm going to kind of get a sneak peek and see what this all looks like. So the maximum, focus in on this number. Try and find out where that's the largest. Well, it looks like it's the highest right there. So I'm going to pick the point to the left. Then it asks me for the point to the right. And then I'm going to pick that point. So notice it gave me, I would call this the vertex of 12 and 16. Okay, I would round that to 12 because it's so close to 12. So going back to here, okay. Okay, the height that that ball reaches, okay, or the, I guess, line that I threw, okay, that is, okay, we did it on the calculator, and it was the 0.1216. So when it asks you, what is the maximum height? That would be 16 feet in the air. All right. So obviously I was a little higher than that because I was on my porch, but you get the point. Now it says, how far from the child does the ball strike the ground? Well, again, let's go back to our calculator. Okay, so this was the maximum. This is the height it started in my hand, the maximum height it got, and we're asking for this point all the way out here. So that point is a 0. So let's go to here. All right. And then we're going to click the right bound. And then I'm going to guess, it looks like it's right about there. So it says that is about, looks like 25.85 or 86 feet. So I would say the answer to C, all right, okay, we found the 0 / root, and that came out to be x equaled 25.86 feet, meaning that I only threw it 25.86 feet. So let's break down the problem from start to finish, okay? Starting, it asked me, what was the height of the line before I threw it? And that was 4 feet. Then it asked, how high in the air did the lime get? And that lime got up to 16 feet in the air before it turned around and started to come back down to, I guess, the ground. Then it says, how far away did that lime land? Well, mine nailed my neighbor's yard. So mine went a lot further than 25 feet. But in this case of the child, it was 25.86 feet. And now when we kind of go back and think about everything, a child is about 4 feet tall from where they would throw the ball. It is reasonable to believe that they would throw it 16 feet in the air if you're throwing it a distance. And it's believable that they only threw it 26 feet, depending on the height of the child. So that is the 8.5 example 1 application.